In this short lesson, we're going to look at adding and subtracting square roots. And to do that, let's look at a couple of definitions. In my example here, I have 3 root 2. The number that we have under the radical sign is called the radicand, and the number that's multiplied out front is called the coefficient. Okay, so we can take square roots or radicals and we can add and subtract them if they have the same radicand, then we can add or subtract their coefficients to combine them. Okay, we can only add or subtract them if the radicand or the number under the radical symbol is equal. So you're going to see a lot of similarities here to working with fractions when we're working with radicals. Okay, so I've got 2 examples down here. Example A is 5 root 2 plus 3 root 2. So if I have 5 of these plus 3 of these, I end up then with 8 of the same thing. So it's 8 root 2. And I've got 6 root 7 minus root 7. The number, the coefficient here, which isn't written, is actually a 1. So 6 root 7 minus 1 root 7 will give us 5 root 7. Very straightforward. However, sometimes we need to simplify before we can actually do the adding or subtracting. So if we look at example C here, I've got 4 root 50 minus 6 root 32. These numbers look suspiciously large, and maybe there are perfect square factors, and in fact there are. So 50 has as a factor 25. So always go through the perfect squares, 1, 4, 9, 16, 25, 36, and check if any of those are factors of the radicand that you're working with. And 25 goes into there, so this is going to be equal to 4 times root 25 times root 2 minus 6, and then think about what's the perfect square that goes into 32. One of them would be 4, but a larger one yet would be 16. So that gives me root 16 times root 2. Simplify, so root 25 is 5, so that gives me 4 times 5, 20 root 2, and the square root of 16 is 4. 4 times 6 is 24, so that gives me 24 root 2. So now my radicands are equal. So I've got 20 root 2 minus 24 root 2. So I end up with negative 4 root 2. Okay, and that is in its most simplified form. Let's take a look at question D here. I've got root 3 plus root 48. Let's take a look at what the perfect square of 48 is, or if there are any perfect square factors for 48. And that root 3 would give you a number to test. So check what's 48 divided by 3. Oh, that gives us 16, which is a perfect square. So this is equal to root 3 plus root 16 root 3. The square root of 16 is 4, so I've got root 3 plus 4 root 3. So 1 plus 4 gives me 5 root 3s. Okay, so that is adding and subtracting perfect squares and square roots.